Hello, everyone, and welcome to this workshop, which is titled Building Smart Reading Assistants with MCP, AI-powered academic paper navigation for healthcare research. I hope you still have some energy left in you at the end of the day and of the conference, because this is going to be the last session for today, and it will be quite hands-on. If you want to already get started with the setup of the repo while we are doing the introduction, you can already find all the material here. You have the link for the GitHub repo. During the workshop, we will be using GitHub Codespaces as well as the free GitHub Copilot plan. So make sure to create an account if you don't have one already. Or you can also just do the exercises with someone next to you. A few words on us. So I'm Gaétan. I'm a lead ML engineer at Visium, and I'm here today with Philippine, who is also a ML engineer. We are both working at Visium in Lausanne. You can find our contact details here, and feel free to reach out to us also after the conference if you want to chat. Just a few words on about Visium first. So we are an AI consulting company which was founded in 2018. We are primarily based in Lausanne and Zurich, but we also have hubs across Europe, the main ones being in Spain, in Valencia and Barcelona. Our core mission is to help companies identify and realize the full potential of the data, from pure strategy with our management consulting teams to the implementation of their platforms and projects with our teams of data and machine learning engineers, of which you can see two representatives today. If you are interested by Visium as a company, if you want to work with us or want to apply, feel free to reach out to us after the workshop. We have a bunch of open positions at the moment in Switzerland and Spain mostly. And we have a few flyers and goodies lying around that we will get out at the end. A few quick summary of the main takeaways that will be in there for you today. So this workshop will be heavily focused on bringing to you the MCP fundamentals. We will present why MCP has become so popular recently, why it's a real game changer for developing real-world LLM-based applications. Okay. You will get familiar with the structure and syntax of the MCP architecture, how it is integrated using various tools such as GitHub Copilot, for example, in this workshop. And then we will exemplify all of this by doing the hands-on part by creating a practical implementation that is focused around the healthcare literature research assistant. This is more or less the summary of the workshop. There will be a quick intro on MCP from a framework perspective, then more from a practical aspect, the core concept behind MCP. And then we will go into hands-on. Please, we'll try to take all the questions during the hands-on part. So feel free to raise your hand at this time. Good. So what is MCP and why does it matter in today's world? So MCP stands for Model Context Protocol, and it is an open protocol which was created by Anthropic in November 2024. Using MCP, we allow AI applications, so your usual Claude, ChatGPT, GitHub Copilot, to connect to various data sources, various tools, and other workflows. It can be databases, it can be search engines, and anything you want to access. This enables dynamic access to key information and ability to perform tasks, such as sending emails, booking events, etc. One very common analogy that is used is that MCP is to LLMs and applications what USB-C is to hardware connectivity. So it's really a standardized way to connect AI applications to external systems, just like USB-C is a standardized way to connect electronic devices together. One interesting aspect in MCP is that it goes both ways. So AI agents can query data and results from tools, but you can also submit data and trigger actions in these remote servers if they are exposed to the right components. What MCP really brings is that it gives life to complex agentic workflows. So through this standardized interface, it makes it easy for various applications to open their services to AI agents. This eases the work of developers and let them create complex workflows in a much more maintainable and modular way by alleviating the need of maintaining different communication protocol and interfaces for each different services. So the responsibility of the application designer is to provide a MCP server to which people will then be able to connect using MCP clients. And so the protocol is standardized this way. One critical aspect that is still requires a lot of expertise today, central security and permission control. You might have seen in the recent months, it has become a dangerous trend to give full access to all the resources to your AI models using things like OpenClaw, for example. This raises, of course, a number of security issues and a lot of challenges around exploitation of vulnerabilities, exposition of API keys, or just even remote access credentials to your machines. So yeah, thanks to MCP, it's really only then the limit of the developer imagination to create complex workflows. So if you work, for example, in sales and marketing, you can connect your ChatGPT instance to your email box, to your database of client through Salesforce, to your Google Calendar, and send personalized outreach emails to each different prospects. If you're a web developer, you can connect your AI app like GitHub Copilot to your GitHub repo, but also to the documentation of plenty of libraries online, and let your coding agent vibe their way through the development. So really, MCP enables tons of different use cases. One potential example and something we've been building at Visium is an agentic platform which facilitates many different processes in the healthcare and life science world. So our platform implements plenty of different AI agents. So like for root cause analysis, for healthcare literacy research assistants, but you can also implement your own agentic workflows there. And then all these agents are connected to each other using agent-to-agent workflows and also MCP to interact with plenty of core business applications and databases hosted in various infrastructures, whether they are hosted on-premise or if they are locally on a computer working in the cloud. You can really go on anywhere. So this lets both our developers, but also our users easily compose new workflows and integrate new functionalities to the AI platform itself, thanks to this MCP standardization. Good. So now going a bit more into the architecture of MCP and how it works behind the scene. So if you are familiar with web APIs, MCP follows a client-server architecture, so we're not really in uncharted territory here. So first thing, the first component is the MCP host, which is your usual AI application. So think ChatGPT or Claude Code. This MCP host is charged of creating and maintaining MCP clients. And each MCP client connects to different MCP servers to obtain information and get the relevant context that it might need. The MCP client is really the core component that is responsible of maintaining this connection to the MCP servers and obtaining the context on behalf of the MCP host. So whenever then you write a query into your ChatGPT, the AI assistant will consider whether answering your question requires the use of an available resource, such as one of your installed MCP server and client, and it will ask for permission to perform these actions or perform them directly if you already gave it the right permission to do so. And so finally, the last part of this is the MCP server on the other side of the communication protocol. So the MCP server is the interface developed by the application provider, and it will provide the context to the MCP client. You can create an MCP server to interface any kind of system, as we already mentioned. And these servers can be run either locally on your own computer to work, for example, with your local files, but also remotely if you want to interact with a server connected to your Google account or your Notion database. Yeah, that's more or less how this goes.
Okay, so now that hopefully you're all now more familiar with the overall architecture, I would like to present you more on servers. And to start with, let's focus on the Python package, something very concrete that we will be working on. And this package is called fastMCP. It's a very lightweight modular package that actually encapsulates all the habitual definition, like declarations, with, for instance, just decorators. So it's very convenient. And here you can see how fast it is to instantiate the server with this library, and over there, how it's like how you can run a server. So 2 lines of code, very convenient. And now to talk a bit more about servers, following the MCP protocol, servers expose 3 types of functionalities that we call primitives. The first one are MCP tools, and these tools are basically functions that are exposed to the LLM in the MCP host in your AI application, and it's the LLM that decides which tool to use based on a user query. Tools can do basically anything. They can write to files, call external APIs, perform operations, they can send emails, they can do something very simple, such as this very simple function here. And in Python, how you would write them, you would write your function and then you will just add a decorator on the top of it with this fast MCP library. So easy to write. The second primitive that is explained in this MCP protocol are the MCP resources. And a resource, it's a read-only data source that can be passed as context to the LLM. And this can include like file contents, API doc, database schemas, and this is accessed by the application. And in this example, you can see how to define a resource. So similar to how you would define a tool, but you would add something called a uniform resource identifier on the top here that would enable the application to access like the right file or schemas or JSON, whatever. And the last primitive that you might be already familiar with are MCP prompts. And for those who don't know exactly what a prompt is, well, I'm sure almost all of you do. These are like basically instructions that would help your LLM into processing some tool calls in a specific order, or to use specific data for the resources in a certain way, or to format the answer. And this last primitive is called explicitly by the user itself, him or herself. And how you would define a tool similarly. You have this decorator at the top of your function. You might want to add a name and a description to it. And very, very fast. So now that you know more about servers and MCP architecture, we'd like to walk you through the full MCP protocol and to give you a sense of how things happen under the hood from your query to the final answer that the LLM will give you. So in this exercise, we will implement a simple MCP host. So if you didn't have the GitHub repo already set up on your computer, the link is over here. And I will walk you through the code space setup. Well, again, I already follow these instructions here. And second thing that you need to do, you need to go to this link to pick the API keys that we will need. So Okay, so this is our repo. And to create the code space, it's very straightforward. Just click here. It will open the code space for you, which might take a while. And while it's setting up, let me introduce a bit more in details what we'll be doing. So we'll be implementing indeed this simple MCP host, leveraging an MCP client that we've already implemented for you and a very simple server. And also this host will enable integration with a model from OpenAI API. So in real life, you wouldn't implement this host or this client yourself, but rather you'd like to pick some already implemented libraries, for instance, OpenAI Agents SDK, but for the sake of the workshop, and we will show this to you. So it should be set up by now. Yes, it is. Yeah, almost. So if some of you already have this, you can create a file which is called .env at the level of your repository. So let me do that again meanwhile. And so once you have the API keys, you can pass them in this env file. Please place this file at the top of the repository. Otherwise, it won't work. So here, click on this one. It should set up for you as well. Just has to detect the virtual environment that has been built. Okay, so if it works correctly, you should see that it already selected automatically the right kernel on the top. Okay, so this, otherwise you do like I did, you close the file, you reopen it. Okay, so here the idea is to walk you through 4 main steps of this MCP protocol, this exchange between the MCP client and server that happens internally into the MCP host. So this happens when basically you're, I don't know, like connecting an MCP server to your Cloud desktop or to GitHub Copilot. And this is what happens internally when you're like actually doing the connection and clicking on small buttons around. So the very first step that happens is that the client sends an initialize request to the server, and the server responds with an initialize response, and so that it enables the client and the server to be aware of each other like capabilities or features. The second step is that the client sends a tool list or prompt list, resource list request to the server, and the server answers again with a list of the available tools, prompts, resources that it exposes. Then the third step is when the client is aware of what the server exposes, it can call a tool with the rights arguments. And the final step is that the full integration with the LLM. So basically, from the user query to the LLM choosing the right tool and to the execution and formatting the final answer. Okay, so the first cells, so these are like helper functions. You can go through it later on, mainly for the fourth stage, the fourth part. And if we go through together, the initialization, you have the server setup. So this is the connection parameters for the server. And then you initialize the connection between the client and the server in the following manner here, in the code here. So basically, you will leverage this class that we've implemented for you. And the server also that we've implemented, and you will always start like this. So you declare this your client, and then you make an initialize request. And you might note, for those who are not familiar with this, that we have like this small async keyword, and basically this is because the client and the server communicate in an asynchronous way. So basically, the client sends a request to the server, it waits for a bit, and then the server answers. So to handle, like to avoid blocking code execution, if you want, like roughly, we will always wrap our calls to the server through the client in this fashion. So to summarize, this is how you initialize the server MCP client connection within the host. Okay, then the second step, and this is for you to play around, is to list actually the tools and the prompts and the resources that are exposed by the server. And to help you, you can execute this magic cell that should like print the full class description of the MCP client. And so so I have to execute the cells above, but basically it will show you all the functionalities that are exposed by the class. Yes, now it works. So you should have something similar. Okay, so here you can list the tools, the prompts. Now that you've listed the tools, here you can see what is the required input for each of these tools. So this is very important because in the tool description, the tool description is the documentation of the tool is very crucial for the LLM to understand how to use the tool, when to use the tool, and so to know which arguments and types are required. So with this, you can choose one of the tools that you want and call it with the right arguments. And then similarly, I can let you go through the following cells. For prompts and resources discovery, that brings us to step 3, where we introduce the LLM. So you will, so you have an API key for OpenAI. So we will use a simple model from OpenAI, and we will integrate this into our loop. So basically, through 3 different steps, as we've described above, we will understand, yes, how the model chooses the correct tool based on a user query. The user query being here, like it's a very simple query with a biological flavor to it. And yes, and finally, so this is the resources and the prompts. Also, you can run these cells and have a look at it. And finally, we will execute and integrate everything and go from really your query through the LLM call, tool call, and then to the final answer. So yeah, feel free to ask questions to us if anything's unclear. And yes, have fun. And yeah, we will go through the solutions in 5-10 minutes. So the first cell that you had to fill in was this one. Very simple, but just to give you a taste of what the server does. And you can see that it has 1 prompt, 2 tools, and 1 resource. The second thing that you could play around with was this tool call. So once that you know all the tools and you know also what it looks like. So for instance, if I pick the second one, you know that this tool is named convert sequence and that it needs as input a sequence, which is of type string, and a mapping string, which is of type string as well. Both are required as input. And if you look at the documentation, you know that, for instance, like the mapping should look like this. Good, so let's call this tool convert sequence with this sequence of nucleotides and then this mapping string. So you want basically to convert A to T and G to C. And all good, it happens as expected. Good. Similarly for prompts and resources, you could like run these cells and then it will print like the prompt or the resource. For the understand and plan, I think there were no to do, but basically this is the query that we define. Feel free to like tweak the query if you want. This is to define like the API parameters. We build the API parameters, we initialize, we register all the tools for the OpenAI calls, and then we actually call the LLM with a list of available tools. We get a message which says, okay, based on this query, convert the follow string in using this mapping. The LLM chooses to call the convert sequence tool with this sequence and this mapping string. That's cool. It like obeyed it followed the parameters and their types. So again, like a small note here, it's like the documentation of your functions is very critical because it enables the LLM to understand how to call the tool. Okay, so you can do the same with the prompt and the resource. Good. And now come the execute and integrate. So as I said, from your query to the final response, this is the query. You initialize the connection between the client and the server. You build your initial API query based on the user query. You list all the tools. Again, you don't forget like this await and the sync keywords, that because of this asynchronous communication. And now with this list of tools, you call your model, and now comes the loop. So while we have a tool call in the model, we basically call the tools. So we add the tool call to the LLM context. We execute a tool call based on the retrieved tool names and arguments with the MCP client. This function is defined at above, at the top of the notebook. So feel free to have a look at it if you like anything isn't clear or if it seems too high level for you. Then we add the tool results to the context, and then we proceed with another call to the OpenAI API, and we get a new message, and we do it until we don't have any tool call, so that the LLM can compute the final answer. And in our very simple case, we just had like one tool call resulting in a final answer like this. The converted string is blah, blah, blah. So you see it's quite simple. And again, if you want to build your own MCP, you don't have to implement everything by yourself. No, you should like reuse what other did. It will save headaches and but basically this is just to showcase. And now we can go for something. Yeah, so this is the solution. We can focus on our intelligent research assistant for biotech. So as I said, now you have like this full overview, but what we want you to experiment with to showcase how MCP is flexible and how also like how powerful this tool is. We want to implement a research assistant that has several features. And the first one is to connect our assistant to a database of research papers. If anyone of you has a biological background, you might know PubMed. This is a very useful database of articles. So basically, we want to make to have access to the latest research, to do research summaries on whatever topic we want. We want to do to have a feeling of research trends. And with this, so we will build our first assistant, and to do so, we won't use the MCP host that you've just implemented, but GitHub Copilot. So you can go back to Codespaces. And you should see this panel on the right, I hope for everyone. Otherwise, you just click on the bubble here. Make sure that it's in agent mode. And for the sake of the exercise, pick a simple model, but you can play around with any model that you'd like. And as I said, our first server that we will, the first feature that we will be implemented is a server, an MCP server, and you can find it in exercises here, PubMed Literature Search server. Okay. But how do you connect GitHub Copilot to this server? How do you make things run and connect? Because, this is handled through a config file that you'll find here. And then you can see how this is called. So basically, it's connected over SDDO. So this is a kind of communication transport layer. And this is the name of your file. So as I showed previously, this is how you run your server with fast MCP run. And you can interactively start or restart your server with within this file with this button whenever you're making major changes or adding tools. And how do you access the tools? Well, the tools should be handled by the LLM call. And here, if you click here, you have all the tools that the agent in this chat session has access to. So I would strongly suggest that you just select agent, if you want, and read. All the rest is not necessary, otherwise the agent will start writing some things to your files or reading something you don't want. And you can also select, the server of interest. PubMed Literature Search, if you click on it, it has one tool. So this is what we want. Okay, so you're set up. And if you wanted to add resources or prompts, what you could do, so resources, as I said, you add it to the context. You click here. And you can browse all the resources that are exposed by your server here. Or if you want to leverage the prompt, you do /, and then you have another prompt that appear here. You just click on it. It won't work, but you will write anything if any parameter is required. And then it should copy paste everything here. It doesn't work because it's not implemented yet. But so for the sake of the exercise, as a small recap in here, you want to connect you want your intelligent research assistant to have an access to all the latest research in biology. And to do so, you build this MCP server that connects to PubMed. And you want to give two functionalities to this server. The first one is a tool that enables API search, this tool here. And to help you write this tool, we've already implemented for you an API client here. And but basically you don't like this, you wouldn't know which function to call, but actually it's quite easy. If you hover over and you scroll down, you can see how to use this API client to make a call to the API. For instance, here I want to look for articles to 5 articles about asthma in title between 2020 and 2021, and to sort articles by relevance. So this is how it works. And a second hint to implement this tool is this eSearch request pydantic model. And as you remember, documentation is critical for the LLM, and this is what we show here. So basically, we've implemented a more complex and very detailed parameter class as an input to your tool. So yeah, the tool is the first thing that you can implement, and the second thing is the prompt. So feel free to change the name of the prompt here or here, and to leverage a helper function. And once you have the two things implemented already, you can play around with it in the chat here. So ask anything that you want. I mean, I put example with a protein, but yes, ask some biological question and see and try to play a bit. You can also, if you have time, you can add another tool. I mean, yes, feel free to modify things around. Your server should be running, and if I look at the solutions, I said you had to implement the first tool, which actually calls the PubMed API with some parameters of interest, leveraging the parameter structure above. And yeah, basically it does the same as described in the documentation. So it initialized the API client in an async manner again, same thing, because yeah. And it makes first a search to the API with different parameters. So the term, like the request, so what the topic you want to make the search about, the maximum number of items that you want to return, the min date and the max date, if any, if you want to, I don't know, list the top 5 papers about insulin between 2021 and 2023. This would be these 2 parameters here. And then how you would sort, like if you want the top 5 or if you want the top, the 5 most recent papers, these are these parameters. Then the API client returns a list of PubMed IDs. So this is the way articles are stored actually in PubMed. And then you call another function, which is fetch one, which actually retrieves the article details, abstract, authors, and so on. And then it returns the full answer to the LLM. And some of you might have noticed that if you look at how the LLM proceeds the tool response, it calls it seems to read from a file. And what happens is that if my intuition is correct, is that the response of the tool is too large to fit in the context window of the LLM. So it doesn't fit into memory. So that's why internally the system, like the host GitHub Copilot, does its own internal kitchen if you want to read the output bit by bit. But this is not something implemented somehow in the code of MCP. Yes. And for the prompt, there is something already implemented for you. So normally my server is set up. I will test with a prompt and see if the tool call works. It should. Okay, so every one of you should have seen like this, how do you call this? Like if the user allow a tool to execute. And you can also see if the parameters are correct. So yes, it follows the structure that I've defined above, like here. So I'm happy. If I allow the tool, then I can see the tool response, and then the LLM would read the thing. So just like it's reading something, and it will return a summary. And again, you can also do the thing with the prompt. So it's this one here. I won't do it here, but basically you would enter a topic and then you would copy paste something here in the chat, and then it can format your answer by the LLM. Okay, so this was one feature of our intelligent reader. And the second thing that we want to do is, let's see. Okay, it's to build a second feature and really to showcase how powerful this would be. If you want to already use the solution itself, you can. But just be aware of how to launch this server, because this server is a bit more complicated, so that if you just use the solution, you can also play around with the MCP server and understand how it works and how powerful this is. But basically the idea here is, now that we have connected our research assistant to a database of articles, we want also to have more knowledge about proteins in details. And to do so, we will build another server that connects first to UniProt, which is a database of protein functions, and so on. But we also want to visualize the protein we are making a search. Making a search about. So to do so, we will use a PDB database, which is just a database of protein structures, like 3D structures. So this is a bit what we want at the higher level. And then at the lower level, how it looks like. One thing which is important, if you look at the MCP JSON, so this is the server that we will be implementing. The connection looks different here. It's to show you that MCP actually, what's very powerful is that you can reuse the code from someone else. You can connect to a server which is running through HTTP here, as we would do. Like this is, I would say, like we kind of mimic a connection to a remote server. So you can connect to a remote server, you can connect to servers running locally or through other things. And that you can, reuse the server from your colleague to connect to your own application. And this is very powerful here. And so, but here, like the server would run internally. So what we would do, we just have to launch the server in a separate terminal. I will show you how to do this with the solutions, just to set up the server itself. So remember the command like fast MCP run in your file. I will apply the exact same thing, but just I will change, we'll trick things a bit. I will change what we call the transport layer so that it will be remote and running on what we call the local host here. So we'll open a terminal. And you can do the same if you want to directly run the solution. And we will run the server from our terminal here. Yes, so everything works well, good. And now you should be able to view it here. So it's called PubMed Search Server. If you click on Update Tools, yes, so the tools are, you can visualize it here. Okay, so this is how to connect the server. But what is this server about? What we want to show you? Two things. One tool is already implemented to make some search on UniProt, so you can already use it. And I don't know, ask the protein functions of the insulin or CRISPR-Cas9, as I put in the example, or whatever thing that you want, or find, I don't know, like some very famous, famous it won't know, but I mean, there is no famous tag in UniProt, but you can say, okay, find me some genes that are involved in cancer, for instance. So this you can do with this tool here, which is already implemented. But now we wanted to showcase how do you implement a resource. So we have one resource which is already implemented, in which basically fetches the structure info for you. So like when you want to know the structure of a protein, basically it's you make an experiment and then you know how accurate the resolved structure is, and also the resolution of it in terms of angstrom, which is like a very tiny measurement unit. So these are like structure info that you can retrieve. So feel free also to use this resource. Remember to use a resource. You click on this, click on MCP resource, and then it will be read protein structure info. So if you click on here, it will ask you for a PDB ID. So yes, just to showcase, and it will be passed into the context of your LLM, and then you can ask anything to it. But yes, so this is from the resource side, and if you want, you can create, like you can write another resource which would fetch the protein sequence. And to do so, you can leverage the UniProt client here by going to the file and understand how to like output the protein sequence. But it's one line of code. It's just like get protein sequence or whatever. But yes, just to understand how the sequence work, the resource work. And the last thing, which is more rewarding, is to show also that a tool can do a lot of things, not only API calls. And this tool is to visualize a protein that you want. So we've implemented helpers at the top of the file to generate HTML files and to save this HTML file to your computer. And basically what you can do with this tool is, okay, please show me the structure of the insulin, or show me the structure of CRISPR-Cas9. And it would generate in an output folder a file like this, which is very ugly to look at. But if you click on the button here, maybe it would work. No, it won't. Okay, so basically, if you retry, you will see that you can visualize the protein itself and just play around the visualization. So this is quite nice. I hope this would work. Yes. Yeah, so basically it gives you this output. And everything has been coded already, but you just suggest your LLM to use this function to visualize, in this case, CRISPR-Cas9, which is quite a cool protein, actually. Yes, so basically, if you want to have a try at this, you can build this resource and this tool, and then, or already, as I said, you can use this comment to already run the solution server and play around with it to see how flexible it is. If you want to add another tool or to look at other functionalities, feel free.
Okay, so I will just execute a query to show you how it would look like, hoping that you could make some progress and understand a bit more. So, like, my server is connecting, it's running. My tools as well are correct. I don't have like all, but I don't want. Maybe this. Okay. Search. So I want to make a more formal search about CRISPR-Cas9 routine. I want to know from which species it is issued. I know, not in this, but I want to find like more general info. I want to find a high quality structure, as I said, like the resolution. And I want also to generate a 3D visualization. Okay, so first it makes a call to UniProt for the gene Cas9 and for the organism name that I want. I want a structure for this organism, so it's correct. And it will retrieve 10 items. Okay, let's see. Okay, run the search. And now it will generate the 3D structure based on its choice of 3D structure from the previous search. Run this, okay. And as you see, there is a file that has been created here. Let's see if I can open this file. Yes, so this is the output. I can visualize my protein and the DNA strand in it, so it's very nice. And I have the explanation here of what it is, why it shows this entry, because it has like a higher resolution, and so on, and what is my file located. So yeah, let's wrap up now. You will be always able to use the repo, so yes, it will be a full access.
All right. So yeah, just a few departing words. Thanks everyone for attending the workshop. Hopefully in this workshop we presented to you all the MCP fundamentals, this kind of server architecture, and how in practice to implement different kind of features, implement the whole MCP host, but how it works behind the scene, and also how to use MCP servers and implement your own if you need. A few takeaways. Well, MCP ecosystem is very flourishing at the moment. There are plenty of tools available to exploit this MCP protocol, and it's definitely here to stay. We've shown Trust MCP, which is one of the big standards to build your own MCP servers right now. MCP servers are super modular, and they enable very fast integration of every possible application you can think of in your AI workflows. And if you want to go further, we have extra resources a bit later in the slides, maybe. Yeah. So some extra concepts, some bibliography. We will put the slides as well in the GitHub repo just after the end of the presentation. But there are plenty of topics you can look into. So we mentioned already security and access control to avoid creating bad MCP servers with bad intent. You can check out also client primitives, which is something we didn't touch on today, but how to elicit requests from the users, for example, is handled by client primitives in MCP. And there are plenty of MCP server available that you can find in MCP registries, for example, which is a great website to discover resources that you can integrate in your workflows. Yeah, so that's it for us. We'll stay here for probably a few more minutes. If you have any questions, feel free to come by. And thanks again for your attention.